10th CBSE Chemistry chapter Carbon and its Compounds. In this video, you are going to learn about the homologous series of alkanes, alkenes and also alkynes. Also, you are going to learn about the characteristics of different homologous series. Hydrocarbons are classified into three types based on the presence of single bond, double bond and triple bonds. All the hydrocarbons with single bond are considered as alkanes. Let us take few examples of alkanes. So the first in the series is methane, and the molecular formula of methane is CH4. The second in the series is ethane, and the molecular formula being C2H6. Now, when I write a condensed structural formula for ethane, I can write it as CH3. Moving on, propane is next in the series. When I write the molecular formula, it is C3H8. When I write the structural formula, I can write it as CH3, CH2 and CH3. The next in the series is butane. So the molecular formula is C4H10. So the structural formula being CH3, CH2, CH2 and CH3. Now observe the series. The first is CH4. In the second compound, we can see an additional carbon and 2 hydrogen atoms extra. Moving on, we again find 1 carbon and 2 hydrogen extra, and this keeps repeating. Further, recall that all these compounds of alkanes have a general molecular formula. Recall the general molecular formula of alkanes. Yes, it is CnH2n plus 2. This is the general molecular formula. When you observe their structure, they all have single bond. So they differ only in the length of carbon chain. So you can see that the length of the carbon chain goes on increasing as one moves down the series. So in the methane, it is only a single carbon, and as you move down, the number of carbon atom goes on increasing, and hence the length goes on increasing. And when you check out the difference between the two alkanes, it is always a CH2 group. Further, they all have a general structural formula, general molecular formula, and share the common chemical and physical properties. Such a group of organic compounds which have similar structure and chemical properties, in which the successive compounds differ only by a CH2 group, are called as homologous series. Now let's define the homologous series once again. A homologous series is a family of organic compounds with similar structure and chemical properties, in which the successive compounds differ by a CH2 group. Now here given in the table, we can see the homologous series of alkanes. Now let's write the structural formula for the same and recall the difference between them. It is CH4 here, CH3, 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 CH2 and CH3 for propane. Moving on, for butane, it is CH3, CH2, CH2 and CH3. Now what you are seeing in the table is the homologous series of alkanes. Let's move on to the homologous series of alkenes. Given in the table are the different compounds of alkenes. The alkene series starts with ethene, followed by propene, butene, pentene and others. Now let's write the structural formula for ethane. So as we can see, there are 2 carbon atoms and 4 hydrogen atoms. So the condensed structural formula for this compound will be CH2 double bond CH2. For propene, it will be CH2 double bond CH3. Butene, which has 4 carbon atoms and 8 hydrogen atoms, has a molecular formula CH2 double bond CH2 CH3. So 2 hydrogen atoms here, 1, 3, 5 and 8. Yeah. So the valency satisfied. Moving on, pentene CH2 double bond CH2 CH3. Now observe here, observe the differences between the 2 alkenes. It's again a CH2 unit. So the successive alkenes differ by CH2 unit. They all have a single double bond, and also all of them have a general molecular formula CnH2n. Because of all these factors, we call this as the homologous series of alkenes. Let's check out the homologous series of alkynes. So it's 2 carbon and 2 hydrogen. So I write CH triple bond CH for ethyne. For propyne, it is C3H4. So I write CH triple bond CH3. Moving on, it's C4H6 for butane. So I write CH triple bond CH2 CH3. Yeah, there are 6 hydrogen and 1, 2, 3, 4 carbon atoms. And for pentine, it is CH triple bond CH2 and CH3. Now observe the structural formula, the condensed structural formula of these alkynes. Again, it differs by a CH2 unit. They all have a general molecular formula CnH2n-2, and all of them have a single triple bond. And observe that the carbon chain keeps on growing down the series. So we consider this as a homologous series of alkynes. The organic compounds such as haloalkanes, alcohols, aldehydes, ketones, carboxylic acids also form homologous series, which you will be studying in future classes. All the compounds in a homologous series exhibit a particular set of characteristics. Now let us learn the characteristic features of homologous series. All the members of a homologous series share a general molecular formula, which we have already seen. Like for example, in case of alkanes, it was CnH2n plus 2. They also share same functional group, like for example OH group or carboxylic group. We can see the similarities in their physical and chemical properties, and this varies gradually among the members as you move along the series. So these are the common things which you observe among the members of a homologous series. So far we learned what are homologous series. We saw the examples, that is alkanes, alkenes and alkynes. Let's do a quick recap of all this. Homologous series. A homologous series is a family of organic compounds with similar structure and chemical properties, in which the successive compounds differ by a CH2 group. So there are 3 main characteristic features. The first being that they share a general molecular formula, and the second, they also share the functional group. Further, they exhibit similar physical and chemical properties which vary gradually as one moves along the series. In this video, you learned about homologous series, the homologous series of alkanes, alkenes and also alkynes. You also learned about the characteristics of homologous series.